All right, so next thing here, so we have another reference page. Whenever you see these things that say like guide or graphic organizer, anything that kind of makes it sound like it's a list, so it's not exactly an in-class assignment, but it is something that's very helpful. Okay, so like the last one was the graphic organizer. So in this case, actually, this one will be very necessary. You will pretty much need it for this next assignment and probably even for the rest of the course, because this list contains everything you're going to need for, I have no clue how long, but it could, again, very well be for the entire course. Most of these you already know. These top ones here, how much are there? Like 9. Yeah, 9. So there are 9 items on this one. There's actually a few more, but these are probably the most important ones that you're going to be using on a regular basis. And most of these you've already seen. So if you were working with any kind of algebra, okay, you have used these properties and you may not even have known what you were using. So we need to use these in what we call proofs. So in a proof, you're trying to show that something, works out a certain way, and you need to show how it works, right? You need to prove each step. So again, make sure you have this page. There's a couple of things you could do, okay? Right now you have a computer, obviously, because you're watching this, or a phone, which would probably mean that you could maybe take a screenshot of this. You could write it down if you absolutely have neither of those things, or if you're like me and you have a Mac and you don't know how to work one. Well, actually, this one's not a Mac right here. I have these two computers, and they are both they're both Microsoft, but they take screenshots differently. So I know it's a little bit different, so I can't tell you how to work your screenshot button or whatever, because it is different for most computers. So if you don't have that, best you could do is probably write it down, okay? So once you copy this in your notes, you might want to copy this into another notebook or something like that. And that goes again for anything that says reference, guide, or what was the other one I just got done saying? Charts. So something like that. They usually kind of break down all of the stuff we've covered into a very short one-page document. Or maybe this one's, well, yeah, it's 1 page. All right, so let's go ahead and get into it. So addition property. Now, again, all of these are very, well, they're pretty simple. And again, you've been using most of these. If you've been doing any kind of algebra, you have been using these properties. So this says that if we have A equal to B, well, I could add C to both sides and it would still be equal, right? And adding something to both sides is something that you would do in algebra. The same is true for subtracting something in both sides. If you subtract something from both sides, then you are doing algebra. Right, and that is one of the steps. If you remember, in fact, I think I went over this last week, and that was the steps. In fact, actually my poster, oh, it's still right here. So remember, we have to take care of our parentheses and like terms, pick a side for the variable, do the add and subtract, multiply or divide, and then check it. So those same things. And same thing with multiplication property too. If you have A equals B, you can multiply something to both sides, the same thing to both sides. If I multiply C here and C there, it's not going to change. It's still going to be equal to each other, right? Everything should be perfectly balanced, as all things should be. Division property means to divide something by both sides. Now this one's probably a lot more common, especially if you have something like just an example, 5x equals 15, right? You'd have to divide both sides by 5 in that case. So dividing something by both sides is something that you almost always do in most algebra problems. All right, distributive property. And this is another one that it's very, very rare that I run into any students that don't know how to use distributive property. It's one of those things that's like everybody knows how to do it somehow. And it's very rare that I don't. And that kind of makes sense, because if you don't know how to do it, it becomes really hard to work past it. And that pretty much says when you have a parenthesis and something in front of it, you have to get rid of that parenthesis by multiplying both of your inside terms by your outside number. So here I have, well, A times the sum of B and C is the way you would read that. So if it's grouped, you would use the word sum, or if it's a subtraction, you would say difference. So A times the sum of B and C is the same thing as just A times B plus A times C. And then we also have substitution property. So a substitution property states that A is equal to B, right? Then A may be replaced with B in any expression or equation. So substitution property, again, substitution makes sense because, you know, I'm pretty sure you've heard of a substitute teacher. If a teacher's unable to work and they want someone to take over what they're doing, then they would use a substitute teacher. Although with the high school, for some reason, we don't use substitute teachers all that often, especially here. But again, that just means replace. Or if you have a basketball team, you know, you might have some players with substitutions, which when they get tired, you switch them out. Reflexive property is pretty much anything will be equal to itself. That's something like 5 equals 5 or 7 equals 7. Okay, both sides need to be equal. And you've seen me do this one before. I know we've done this one. And in symmetric property, that's usually when I will flip something. You know, I'll flip the term. So here I have A equals B. Well, we could also say B equals A, and it would still be true. Now, an example I might have with that one is something like 5 equals Y. Well, just flip it around so it says Y equals 5 now, and that makes a little bit more sense, reads a little bit better, okay? So it just makes it a little bit better when you're showing the answer in an algebra solution to have your letter or your variable go first and then what the value of that letter variable is. And I was talking about this one earlier. So last one here is going to be transitive property. So I know the word trans, you probably heard it before, like words like transit or transmission. Or a homeless person can sometimes be called a transient. So trans kind of just means to go from one to the next. Like a transit station is where you would go for buses. Transistor radio would mean all the circuits that go into it. What was the other one I gave? Transmission is a way for energy to go through some gears to power the wheels on your vehicle. So again, it just means to go from one to the next, to the next. And I think I told this story before in the last class, and that was, imagine that you play basketball with one of your friends, and your friend is about the same size, the same height as you are. And your friend says, hey, I'm gonna invite my cousin over to play basketball. And you ask him, just because in basketball, it's kind of important for height to be known, I guess. You know, he might say, well, my cousin's the same height as I am, right? So he's telling you now, my cousin is the same height as me, and you know you are the same height as him. So you can pretty much deduce that you are the same height as this person who you've never met before. And that's transitive property, pretty much. So again, A equals B, B equals C, then A equals C. And that kind of follows the same logic as the one that we were just working with. Excuse me. Now I forgot what it was called. The reasoning that we just got done covering. Darn it now. Oh, this one here, syllogism, right? Because again, P equals Q, Q equals R, and P would then mean that it would equal to R. All right, so I'm gonna go ahead and go down here. So this is the next part here. And what's going on, especially on your page, you're gonna see that there are some, well, it's blank, okay? That side of your paper is blank. So what you're gonna have to do is look at these, what's going on in each of these statements, and you are going to name the property that happens in each of these statements. All right, so I'm gonna go ahead and let you work on that for a second or two. I wonder if this Arizona tea is made in Arizona. Okay, it says American owned and operated. Woodbury, New York. What the heck? Why don't they just call it New York tea? But then again, I wouldn't want to drink anything from New York either. Sounds kind of like it would be dirty or dingy or something. Not that I've ever been to New York. All right, so let's just go ahead and get started on some of these. All right, if K is 3, then 3 equals K. And again, they're switching the sides, and I do this a lot too. Like normally I'll have something that looks like this, 3 equals K if I'm solving. I like to keep my variables positive, and to keep the variables positive, you know, sometimes you have to move it over to the other side. And if it ends up on the other side, we'll just work out the problem as normal and then have them switch sides in the last step. So that's exactly what's going on. Symmetric property. And symmetric, you know, you kind of know what that means. Symmetric means that whatever's going on one side, it's going to be the exact same thing going on the other side. So symmetric means that it's not really, I mean, it is going to be the same on both sides pretty much. All right, next one here. Now with some of these, you can't really tell at first, you know, just looking at it really quick, you can't really tell, well, what's going on with it? So you have to kind of ask yourself, what is going on with it? What happened to it? So what happened from 2x equals 14 to x equals 7? Well, we divided both sides, right? And it's kind of hard to tell here because you might think, well, okay, they just gave us the solution. Which, yeah, I can see how you might think that. But what they did was they divided both sides by 2. When you divide both sides by 2, especially when you have something like 2x, remember that means 2 times x. And if you do the inverse, that is the opposite of it, then it cancels that operation. So if you divide it, that is the opposite of division. So now there would be no more 2. But I still have to take 14 and divide that by 2, and that's where we get 7 from. So that would be the division property, right? Because we divided both sides. All right, moving on to number 3 here, 10y equals 10y. So again, reflexive property just means it's the same thing on the other side. And it's not switched or anything. It's not like commutative property or anything like that. It's 10y, 10y. So it's the exact same thing on both sides. Sometimes we do that when we're checking work. Like if you have a solution and you're not sure if it's going to work, you might plug it back in. And if you get something like 5 equals 5 or 10 equals 10, then you know you got the right answer. All right, so let's see what's going on from here. So now sometimes it can be a little bit confusing because they have these if and then statements or ands and all these other things in there. And some of these look really long and you're looking at them being like, oh no, that's complicated. Okay, so just take it one step at a time and look at what's going on. So here I have negative 5x minus 1 equals negative 11. Okay, so what happened from here to here? And again, they give us another if and then statement. If this, then what happened here? Well, let's look at what's different. So you might remember those old children's puzzles. Like it's like a picture. They have like 2 pictures. They look the same at first, but then they have you looking for the little things that are different between the 2 of them. And that's what's going on here. So I have 1, the negative 1, it's gone. Where did it go? Well, they must have done something to get rid of that 1. So where did it go? Well, maybe, well, they did the inverse, right? They added 1 to both sides. So if they added 1 to negative 1, that would be 0. There'd be nothing left. But then we'd have 1 here. So negative 11 plus 1 would be negative 10. We have a little bit of a less negative number. So adding 1 to both sides would get rid of that 1 and change the negative 11 to negative 10. So that's what they did. They added something to both sides. That's why we put here addition property. Now some of these are, again, are pretty long, kind of like this one here. So if 10a is equal to 2b, and 2b is equal to c, then 10a equals c. So again, it's just like one of those syllogisms.
Syllogism, syllogism, syllogism.
Okay, enough of that. So yeah, it's kind of like that. If one is this, then this is that. Then that means that is this. So transitive property. And be careful because there's some other ones that I think they also have ifs and then, or they have the ands and thens, but they may not be transitive property. So just remember, look at the first one of this one and see if you can get to the last one of this one here. And that middle step is the part that joins them together. All right, let's get to the next one. Number 6, negative 7 times the difference of n and 4. And I know a lot of students, if I ask them, how would you say that? They would say negative 7 times parenthesis n minus 4. And that's true, but that's actually not the way you would say it if you were big on math. And that's the way I say it too. I use the word sum, different, product, or quotient if it's grouped. When you hear those words, sum, product, quotient, or difference, that means do those first, which means when writing them out, they belong in parentheses. All right, so what happened from here to there? Well, it looks like they multiplied both things by negative 7, right? Because negative 7 times n would be negative 7n. And negative 4 and negative 7 would be positive 28, because a negative times negative would be positive. So what would that be? Multiplication property? No. Right, this one's kind of a special one. It's a lot like, well, you do use multiplication in it, but it's a special property. And actually, a lot of people don't know this, but you can also use that property, distributive, in division as well. So it's not technically a multiplication property because you can also divide something in a group. But anyway, let's go ahead and move on. That would be distributive property. Number 7, if 6y equals 24, then 6y minus 3 equals 24 minus 3. So what do they do from here to there? Now this one at first doesn't make a lot of sense because you're thinking to yourself, wait a minute. Why did they do that? That doesn't make any sense. If you're trying to solve a problem, if you're trying to solve an algebra problem, solve an equation, you wouldn't do that. You wouldn't make it more complicated. You would try your best to simplify at every step. But just because they do something doesn't mean it can't be that property. They did subtract something from both sides. Right? They subtracted something from both sides because they minus 3 from both sides. Now, there could be a couple of reasons you might want to do something like this, but I'm not going to get into them. Number 8, if 10x plus w equals 41, and now we learned that w is 1, then 10x plus 1 equals 41. So what's the one thing that happened here? Well, we substituted it, right? There was a w. We learned that 1 is w, so we replaced w with 1. Now instead of 10x plus w, we say 10x plus 1. Now we can solve it if we wanted to, and that's probably what's happening here. We had to know what 1 is before we solved it because there's always the chance that, if you have two variables, it's really difficult to solve something when there's two variables, pretty much impossible. So you have to narrow it down to one thing. All right, number 9. If 3x equals 2y and 2y is the same as z, then 3x equals z. All right, and again, there's quite a lot of ifs and thens. Well, we also have an if and then here, but that was a substitution. So if you have an if and then that could be transitive or it could be substitution. But again, let's see if this statement, 3x, and they're joined by 2y in the middle, right? So one ends with 2y, the other begins with 2y. And the last thing is z. So the first thing and the last thing should be the same as well. And that would be transitive property. Again, it's like finding out the height of somebody, asking somebody else. All right, addition property. So addition here. Oh, sorry, I read the answer first. Anyway, we know we're adding something to both sides, right? 7m equals 35. And if I add 4 to both sides, it's still going to be the same thing. And you use this all the time when you're working on algebra problems. Okay, when we do algebra stuff, always we are adding something to both sides or subtracting something from both sides, multiplying or dividing something from both sides. Okay, so here I have negative 2c equals 18, then 18 equals negative 2c, and that would be symmetric property. So again, we're just switching the sides of which one the variable goes on. So again, I would normally be switching something like this to be something like the first one there, because that usually makes sense a lot more when you're dealing with math. It makes a lot more sense. So I'm not sure why they did it that way. It doesn't make sense, but again, sometimes these things don't make sense. We just have to find out what's going on. So next one, 3x squared plus 1. Now we know that x is equal to 5. So what we're going to do is we're going to take that 5 and plug it in. So again, that is substitution property. And I know plugging in is generally what you hear other teachers calling it. And I remember that's a lot of my teachers used to call it that too when I was in school. They used to say plugging in. And I think a lot of students say that too. They'll say the word plug in. But the real word, the actual vocabulary word for that would be substitution. Oopsie, sorry. I didn't notice I pushed the stop button. All right, where were we? Multiplication. So here, it looks like what's going on from here to here. Well, it looks like we just multiplied both sides, right? So we use multiplication property on both sides. And from here, now this one's a little bit confusing because it is actually backwards from the way you would think about it. So the backwards here, 5x plus 8. I'm sorry, 5x plus 8x. Well, isn't it normally the other way? Aren't we going x times 5 and x times 8 to get something like that? Now, it is backwards. Again, it's going backwards. But it would still count as distributive property. Now, I don't think there's very many people in this class. Let me just look over the list of who's here. Okay, maybe one person. Maybe 2 people. Oh, definitely him. So there's about 3 of you who have been in my class before. And I called this specifically, it's my own word for it, I call it reverse distributive. Although, again, what's happening here is what we would call factoring. But reverse distributive is when you take something from both people. So in a way, we took the x from both of these people, the 5 and the 8. And again, normally that's considered factoring, but again, distributive can work both ways. So let's go ahead and move on to the next thing here, and that would be using them in proofs. Okay. Sorry, I just want to get that out of here and get that done with. Again, I ran out of water, so the building doesn't have any water in it, unless I want to drink out of the bathroom sink, but nope, not for me. They used to give us water bottles, but they don't do that anymore. So I didn't manage to bring any water in today. I left my water bottles here yesterday, and I'm down to my last bit of it here. So I had to go grab something else to drink. Yeah, they used to give us water bottles, but no, they stopped doing that. And the water fountains are blocked. All right, so hopefully you at least copied that first box, the one that says, what is a two-column proof? So column are the things that go up and down, right? So if you're in a building, they might have these big thick poles that hold up the ceiling, or maybe like a small roof or something. That would be a column, right? So columns go up and down, and rows go side to side, which we're not talking about rows today. But a two-column proof is a common format used to organize a proof. So you have two things. You have a statement here on the right side, and then you have reasons on the right side. Left side. Left side is statement, right side is reasons, right? So the reasons are going to be from that list that I just got done showing you, that one that we just covered. And I told you to copy that down somewhere else, you know, whatever it takes. Take a picture, take a screenshot, copy it down onto a notebook, because you will need that. And if you turn in your packet, you will lose that. And, you know, if you rip it out, you might also lose a page because it's printed back to back. So there's a chance that you might, there's a chance that you might lose it, you know, lose a homework or a lesson turning it in. So that's why I'm telling you to make sure you get a copy of it. Now, what can be used as reasons? So the properties, again, that's the page I just got done telling you to, that's important. There are definitions. So you might say something like, is the definition of a complementary angle, or, you know, definition of acute angle. You also have postulates. So something might say, you know, we've covered a few of them, like angle addition postulate, segment addition postulate, and a couple of other ones. There are also theorems. Now, since most of you are retaking geometry as this course, so this is a review course, you're probably familiar with Pythagorean theorem, the a squared plus b squared equals c squared. So those sort of things can be used as reasons. So those reasons are, why did this happen? So looking at our statements, what happened from here to here? And just as a hint, the first one is always given. Your first one is always a given. So you notice that it says here, given that 4x minus 1 is 27, prove that x equals 7. So that's what we're doing. That's why it's called proofs. So x equals 7, drop that here. Start with 4x minus 1 equals 27, and that's our given. So we always start with a given. I know one thing that usually happens with students is that they'll have a shift. So they'll move each of those up. So we have 3 things in there, and they'll move each of them up and then kind of skip the given part. So don't skip the given, because I know that's one of the things that usually happens. All right, so let's look at what's going on. So again, from the last step to this step, what happened? So the 4x is the same, but the minus 1 is gone. What happened to that minus 1? And why did 27 become 28? So we have to look at what's different and think what happened there. Well, we added 1 to both sides. Since we added 1 to both sides, that is the addition property, right? Adding 1 to the, it's just like if I have a weight set, right? If I'm lifting weights and I add 1 pound on this side and 1 pound on that side, it's still going to be equal. And that's the important thing, because you don't want like one buff arm and one like not buff arm. So that's what happened. So since we added from here to there, that's the addition property. Now, starting from that last step, we're going to go to the next step to x equals 7. So what happened here? So where did the 4 and the 28 go? Well, we divided both sides by 4. So divide this by 4, divide that by 4. And now we have our division property. So we divided both sides. That's how we got the division property. All right, I'm gonna go ahead and move down here so that way we can get these other two out of here. I don't know how long we've been going on for. But I think there's gonna be 2 more pages after this. So again, it's a bit of work. You know, they're working from one step to the next. And if I remember right, Mr. Moreau told me that this was what students kind of had problems with. It was the proofs that they needed to do. So again, you're basically just looking at this step and this step. So what happened between these 2 steps? All right, so we have +2, and now it's gone. So where did that 2 go? Where did the +2 go? Well, again, in algebra, you generally do the inverse, the opposite of what's going on. So we -2 from both sides. So 5 minus 2 would be 3. And that 2 is gone. It's canceled out. It's canceled out. That's what we call it. So we call that the subtraction property because we subtracted something from both sides. And again, from the last step to this step that we're writing it on, what happened? Well, okay, so where did the 6 go? And this one's a really confusing one. I get this one, students miss this one all the time, and it's usually one of the first things I do in my class, because I get so many students who look at this and they're like, what's happening? Where did, you know, what's going on? Or if I show them this problem and I tell them, okay, what will A be? They'll be like, oh, it's supposed to be 2. Wait, is 2 divided by 6 3? No, that doesn't make any sense. So I usually ask them, like, what can I put in for A that I will divide by -6 so that I get 3? And then after a while, they start thinking, okay, what about 12? What if I put 12 in there? 12 divided by -6 would be -2. Oh, okay, I think I know what to do. So they make that number bigger, and that's exactly what you're going to do. But another thing I'll show them to do is look at the A. What is that A having done to it? What is this -6 doing to the A? It's dividing it, right? Because when you see a fraction, that's another way of writing a division. A is being divided by -6. So what is the inverse of divide by -6? Well, times it by -6. So if we times both sides by -6, 3 times -6 is how we get -18. So we multiplied both steps. So that's why we put in multiplication property. Okay. Now let's go ahead and go to the next one here. So given, so we take that, put it in the first thing, and we say that that's the given, right? Nothing happened. That's where we're starting from, because we can't say anything happened because there's no steps before that. So first thing we got to do when we're working on any kind of algebra problem is they take out the parentheses. If you have any parentheses, take care of those first. So what we did is we multiplied both of these terms by -9. So times that by -9 times this by -9. And that would be the distributive property. So we distributed -9 to both sides, both terms in that group. And then from here, we should get rid of this 27. So we're going to minus 27 from here and there. Now, I also know that you're used to doing a problem, right? Because when we've done problems in the past with this class, we have generally shown each step. So I'll generally show something, and I'll just go ahead and give a quick example. Well, in a minute. So we're used to seeing, come on. We're used to seeing the steps. So like in that case, you know, the 27, we'd show what happened to the 27 on both sides. So we would write, you know, minus 27 here, minus 27 there. But here they don't have that. It doesn't have the, it doesn't have that. Yeah, it just doesn't have that. So you kind of have to go with something that's the steps without the actual showing what happened. So I'm going to go ahead and go over to some of the things that we've covered now in the past. So where are we? Here we go. So something like this, right? We're usually used to seeing something like this. So we start with something, and these lines show that I'm combining these two things here, my like terms. Then we pick a side for the x to go on. So in this case here, I decided to move x over to this side, although normally that's not something I would do. Then it shows here that I minus 15x. Here it's showing that I'm minusing 36 from both sides. Here it shows I'm dividing both sides by negative 16. Right, so I'm showing you each of the steps so that they're easy to follow. I can understand sometimes that it is a little bit difficult to look at this and say, oh gosh, what happened from here to there? Okay, because it doesn't have that in there. So one thing you could do, and I think this will be on the next one here, is to just kind of look at what do you think you would do next, right? You would divide both sides by negative 18. So that's what's going on here. We divided both sides by negative 18, and that's how we got negative 2. All right, so we have this page, and then we have this next page. So I am probably going to do just one of these, and then that might be it for today. All right, so I'll go ahead and leave the other one to you, maybe. All right, so we have our given, and or maybe I'll just go through them a little bit faster. Okay, so again, the important thing is to write these down because you're saying what happened from the last step to this step, right? And that your reason goes here. So what's going on from here to there? Well, it looks like we minus 6x from both sides because look, the x is gone. We only have 1, and it's over on the right side because we minus 6 from both sides. That's why we have 2x. So we subtracted something from both sides. All right, so since we have x on this side, the right side, we're going to have to add 18 to both sides. So 17 plus 7 is 24. So that's where this 24 came from. So that means we added something to both sides. From here, again, think about it. What would you do from here? Well, divide both sides by 2 because we want that x by itself. So if we divide both sides by 2, x is going to be by itself. 24 divided by 12 is going to be, 24 divided by 2 is going to be 12. Now we have that same problem. Well, let's write down what we say happened. So what happened was division. We divided both sides by 2. And then from here, from step 4 to 5, we just switched it. We switched the side. So that would be symmetric property. So by switching it, we now have the symmetric property. And again, we're not trying to solve it because in this case here, we already know the solution. We're just trying to show what steps we used to get there. So it's just like any other algebra problem. We're just naming the steps that happened to go from here to there. And again, there are quite a lot of things that can happen from one step to the next. But it's important just to keep an eye on what's happening. All right, so from here to here, negative 7 times the sum of x and 2 plus 4x equals the sum of 6 and times the sum 6 times the sum of 2x and negative 4. Ooh. Or I could say the difference of 2x and 4. So that's our given. That's where we're starting from. Okay, that's what we were given. Distributive. So we took care of 2 distributives, right? So since we took care of 2 distributives, I just have to write it once. Now, if you were working this out, you could probably write it on there twice. You know, do one, then write that down, and then do the other one. But in this case here, since we managed to do the same step on both of them, we'll just go ahead and write distributive property and take care of those 2 steps. Now simplify, this is what you call, or this is what I used to call, take care of the terms on the same side, the like terms. right? So here I have 7x, or sorry, negative 7x plus 4x. So by combining those, I am simplifying. And we can call anything that happens on the same side, and that's the key, must happen on the same side, then it is considered simplification or simplify. So now I have no more like terms here. So now let's go to the next step. What did we do from here to here? It looks like we minus 12x. Now I moved x over to this side. Well, actually I didn't do it, but we're looking at whoever's work this is. They moved 12x over to the other side by minusing 12x. And that gives us negative 15x. So what happened there was we subtracted both sides. And then here, from here to here, we want to get rid of this 14. So we add 14 to both sides. By adding 14 to both sides, that's how we get this. And we write down addition property here. Now, I need to divide, right? So divide both sides by negative 15. And again, it does seem kind of hard sometimes, I know, because you're used to seeing things with, you know, it's like, plus 5 on both sides or plus whatever to both sides, plus 14 to both sides. You're used to that. And now we go from doing something like that to all of a sudden just being shown the steps without being shown how each of those, you know, without being shown the work, basically. So in this case here, we divided both sides by negative 15, and that gives us the division property. And for number 6 and 7, well, we don't actually, well, on your worksheet, it would be blank right here. So you'd have to fill that in yourself. So given 3x plus 1 is equal to negative 14, what do we need to do? Okay, so again, that first step is always to show your given. So this is what we were given, and we say that it was given to us like that, okay? Sort of like maybe if you borrowed something and you give it back and they're like, why is it all this way? Why is it scratched? Well, I was given it that way. Okay, that's not a good excuse. It annoys me when people do that. You know, especially when you give them something like an old CD game. I know most games are online and downloaded now, but you know, it would always be bad when I'd let somebody borrow a game of mine and then it would be all scratched when it came back. Oh, it was given to me like that. No, it wasn't. Anyway, so let's see what happened. Looks like we minus 1 from both sides. So that's the subtraction property. And then after that, we have 3x equals negative 15. And it looks like, well, what we would do, okay, thinking about it. Now for this one here, what you could do is work on a separate piece of paper, work on a scratch paper. Work on that scratch paper, and you can show each of your steps work, but you will need to show what's happening to the main problem, the main equation, each step, okay? And I know sometimes you might skip a step, so be careful with that. So anyway, divide both sides by 3, and this is what you get. So since you divided both sides, that would be called division property. All right, so last one for this page. Okay, so first thing is we show our given, right? 2 times the difference of x and 9 equals negative 10. So just write that down right here. And write down the given, because that's what we're starting with. We didn't do anything yet. From here to here, and again, I know a lot of students, they have a tendency to shift these down or shift them up, whichever way. You know, it's like they say that what they're going to do next, I guess, is the way you would say it. But no. Again, look at the last step to the line you're looking at now. So in this case, we're looking at line 2. What did we do from line 1 to line 2 to get the reason number 2? So, okay, well, we multiplied both things in this parenthesis by 2 times 2 times 2. Since we multiplied using a parenthesis, that would be distributive property. So we take care of parentheses first, do your addition and subtraction. So in this case here, it looks like we're adding 18 to both sides. So add 18 to both sides. That cancels this negative 18, but it also changes this to 8. So again, addition property. From here, 2x equals 8. We're trying to find out what line 4 would be. So 2x equals 8. So that would be the addition property. We're adding something to both, we're dividing something by both sides. I was just looking over. Right, we divided both sides by 2. And that's where we get x is equal to 4. So now we know that x is equal to 4. And you don't really need to do a whole lot of solving. Okay, so in this case, we know the solution. They gave us the solution. It's x equals 4. All right, and again, I'm looking at the time. Maybe we have enough for one more page because I know there is going to be one more page going on here. And it looks like these are all the really tricky ones that are going on. Okay, so start with the given. And don't forget, actually, this is going to be part of the video as well. So if you miss anything, we're kind of cutting it close. Again, I'm going to have a meeting after this. So I want to make sure I'm ready for that and not going overboard. So normally I'd ask if there were some questions, and if we do have some time at the end, we'll go over it. But I'm thinking that for anytime that we don't have something like covered all the way, you know, it'll be in the video. Okay, so I'm still posting videos. I asked my first hour this morning, like, should I keep doing the videos? Because, you know, if you're required to be here to the Zooms, then you shouldn't be missing anything. And I had a lot of students saying, yeah, but you should still continue the Zooms. And I guess that makes sense. Okay, there's a lot of reasons. You might be logged on, you might be at your house, but for whatever reason, you need to get up and, I don't know, turn off a sink or do some work in another room for just a few minutes. And if you miss anything, that's what the videos are for. So anyway, let's go ahead and get back to this part here. So we have our given. Where did the 2 go? 5y minus 1 all divided by 2. Well, actually what we did was we multiplied everything by 2. Everything got multiplied by 2. Multiply by 2, and that's why that 2 is gone. So again, this 2 is dividing this group. So if we times it by 2, that's where it goes. It's gone now. That's why 7 has become 14. So we multiplied both sides by 2, so that would be multiplication property. From here, it's kind of the usual stuff, right? From here, you add 1 to both sides, then divide both sides by 5, and then you get y equals 3. And again, this is a remedial course for most of you, so I'm going to kind of skip the basic ones. This last page, I think, is mainly for the really tricky steps, because there are some steps that can be pretty tricky. So here we have our given. And what happened here? It looks like we minused 2k from both sides. So minus 2k from both sides. 10 minus 2 is 8k. All right, so yeah, we did minus 2k from both sides, so that would be a subtraction property. We got to get rid of this negative 4. Since I have k on the left side, that means regular numbers have to go right. So negative 4, add 4 to both sides. By adding 4 to both sides, that turns negative 20 into negative 16. And don't forget your rules of adding numbers to negatives or subtracting numbers from negatives. Remember, there are some kind of rules that you have there. And it's not really that bad either. Just a few simple things you got to remember. But I do get sometimes students that will forget those things. Anyway, back to here. So we have 8k equals negative 16. Divide both sides by 8. And that's why we put division property here, because we divided both sides by 8. And I'm going to move down. I think that's it for this one here. And here we go. Start with our given. So put down what exactly it has written here. And then write given, because again, we can't do anything with the first step because, well, it is the first step. So again, take care of your parentheses. Use your distributive property. So that's what we did. So write distributive property here. And added something to both sides. So we want to pick a side for our variable to go on. And again, this just follows your basic rules of algebra. If you're not sure what's going on, sometimes it might help to think, okay, what would I do in this situation? what would I be doing here? Well, I'd pick a side for the variable to go on, and that looks like what they did. That's why there's no 5w here, or negative 5w, because it looks like they added 5w to both sides. Now, okay, this is not exactly what I would have done, but it is one of the things that you can do. Now, we still have our negative here, right? I would have liked to have switched these in the last steps. That way we would use our symmetrical property. But either way, add 8x to both sides. So add 8x to both sides, divide both sides by -3. There you go. Take care of our parentheses, simplify, subtract. And that one, last one seems pretty straightforward. I don't see anything that would be really tricky. But anyway, there we go. So that's it for today. That's our lesson. But hold on, don't go anywhere just yet. Remember, we still have the independent student learning. I wrote it down on the board so I wouldn't forget, because I've been changing its name every single day. So this way it's a little bit easier for me to keep track of the time. I was also going to talk to you guys about the grades. So if you remember last week, what I was trying to do was that I was trying to keep your scores from the springtime. So like, again, if you barely failed, like you got just a few points lower than you needed to pass, you wouldn't have to do a whole lot of work just to keep, here. That's what I was trying to do. But I talked to some of the other teachers and they said something like, well, you're gonna have to work with your old teachers. So for most of you, that would be Mr. Moreau or Kodagiri or Torres, okay? Or I keep calling her Miss Torres, I don't know. I've worked here for a long time. That's what she's been for a long time. Miss San Jose. But you gotta make sure that you have those, you would be working with them and get your grade from them. That's what I also heard. And now there's these two big options. It's like, oh no, which option do we go with? Which one, are we gonna do? So I'm not even sure what was gonna happen. So what I did, and well, I also did a third option, and that was I gave my book, my grade book from this past spring, I gave it to the new summer school teacher. So for me, that would be Algebra 2 students, and Miss Labajo is teaching Algebra 2, so that would be her. So I gave her my grade book, basically saying, okay, take it over. and then I was thinking Mr. Moreau and Mr., all the other geometry teachers would have done the same for me, but they didn't. So again, I don't know how grades are going to go, but at the meeting yesterday, and this is the important part, is that it's going to be an average. All right. So let's say you got a 60% in your last class. Okay. So you got a D grade. Well, in order to get a passing grade of a C, you would need at least a B. Okay. If you had a 50%, an F, you would need a 100% from this course to get a 75%. Now that doesn't really seem to add up. Like, I don't know, but they said that it was going to be an average. So if you got a 0% or anything like 49%, that would mean it would be pretty much impossible for anybody to pass summer school if they got through the spring semester with 49% or lower. So again, I'm not sure how that's going to happen, but I also think that they want us to start over from 0. Which if my bosses tell me not to do that, then that means I'm gonna have to start all the way from 0, which means all of you guys are gonna have to start with this whole course in the summer, doing packets 1 through 4. Basically what you did last spring doesn't count. You're just gonna have to take over this course from the beginning and complete it just like everybody else. And that kind of works out because I don't know what Ms. Torres teaches. I don't know, I'm sorry, Ms. San Jose or Kodagiri. I don't know what they use. I know Mr. Kodagiri uses a textbook. I don't use textbook. I use this thing right here you're looking at. The online thing. So in a way, it's kind of the most fair for everybody, But that's kind of where the grading is right now. There's not really like a there's not really a 100% solid option, but it does come out to basically be an average is the biggest thing that I'm hearing. We're gonna have another meeting today to kind of clarify that. I'm guessing what it is. And then there's also the thing about grade improvement as well. So again, that's working with your old teachers. And again, some of this doesn't really make a whole lot of sense, but we'll see. I'll clarify some of that, but I'm just letting you know right now that for now, the policy is kind of leaning towards, we're gonna work with these packets starting from 0, pretty much. You're starting this summer course right now with 0 points, and you work your way up to whatever points you're gonna get at the end. Then when you get to the end, we are going to be taking the average of those two scores. And I'm pretty sure that the average is gonna be a little bit heavier in the summertime. It's going to be the averages are going to be a little bit heavier in the summertime. So that way, even if you got like, again, a 40%, somehow you'll still be able to pass, okay, without getting a 100%. So we'll see. We'll see how that works out. One other really quick announcement, packets. I sent out packets yesterday. So there were packets 3 and 4 will be sent together, because I don't want that last week. I don't want students being like, oh, I haven't got my packet yet. All right, so it will take time for your packet to show up. Sorry. You know, I wish there was a way to make it go faster. You can always pick your packets up, although we mailed them out yesterday. So at this point here, you won't be able to. I know some of you guys were saying that you were missing your packets 1 and 2. Make an arrangement with me somehow, and I will try to run one out to you. And it's kind of hard because I just realized that we don't have somebody in the front office all the time. So yesterday, I thought a student was going to get help, but I walked up to the front and I noticed that there was nobody helping anybody. The whole building there was nobody in it. So I was like, oh no, what's going on? And I had to go get the packet myself. So sometimes that is something that we have to do. Okay, sometimes that's just something we have to do. So if you can email me saying that, hey, I'm gonna be there in a few minutes to pick up the packet, all right? And it's kind of hard, but you better be there when you better say you're gonna be there, because you know I'm gonna be spending a lot of time waiting for somebody and something, because again, we don't always have somebody in the front, which makes it kind of hard. So if you're missing any of the other things, I sent them out. Check with your new packets, okay? Some of them were so full that I couldn't fit any more stuff in there. They were just too full. So even though I know I said that I was going to try to send out the rest of it, I did not manage to get them. So if you don't have them soon, yeah, just try your best to get a hold of them and make another, make an arrangement with me to pick it up. All right, so that's it for now. I'm going to go ahead and we're going to go into independent student learning. All right, see you there.